This is a video for section 7.1 on the Pythagorean Theorem. We're going to use all of the skills that we've talked about in our previous videos to do a few problems. We're going to find the missing lengths. Answers need to be in simplest radical form. That's really important. That means when you write your answer, you're not going to have a decimal. So here's a right triangle. We know two of the sides. We don't know the other side. So we can find it using the Pythagorean Theorem. Remember, if you want the hypotenuse, we're going to add right here. These are the legs. This is the hypotenuse that's unknown. So we're going to take a leg squared plus a leg squared, and we're going to add them and take the square root. Six squared is 36. 4 squared is 16. (36 plus 16 is going to give you 52. Now, this is where you need your perfect square list. Is 52 a perfect square? Definitely isn't. So what you need to do is, I'll just go back to the perfect square list. 52 would live right here. Find a number that goes into it. If nothing goes into it, then it's simplified. You can just leave it like that. 49 doesn't go into 52, 36 doesn't, 25 doesn't. 16, I'm not so sure, so I'm going to do 52 divided by 16, and it gives me a decimal, so that doesn't work either. I'll do 52 divided by 9, because that's the next perfect square. That gives me a decimal. How about 52 divided by 4? That looks good. 52 divided by 4 gives me 13. So I'm going to show you what that looks like. Instead of leaving this as the square root of 52, you're going to write it as 4 times 13. And I'm going to make the 4 a different color because it's a special number. That special number is a perfect square, and that's why we did this. There was a perfect square that lived inside of here. That broke this rule number 1. You can't have a perfect square inside the radicand, and we did. So now you just evaluate, and this is easy to do now because the square root of 4 is just a whole number because 4 is a perfect square. The square root of 4 is just 2, no radical on it at all. The square root of 13 does not simplify. There's no perfect squares that go inside of 13, besides 1, but 1 goes into everything. So here's your answer, 2 square roots of 13. And it might seem weird to write your answer like that, but this is the exact answer. And you might think to yourself too, well, this is 2 times something. Maybe 6 is bigger than that. I guess it could be, but the square root of 13 is really close to the square root of 16. And the square root of 16 is 4, right? So this is a little bit less than 4. 2 times 4 is 8. So this is going to be a little bit less than 8. That's how you can kind of approximate that in your head. We're going to do this one as well. It's a right triangle. We know 2 of the sides. We don't know the third side. Our third side this time, the side that we don't know, is a leg. So instead of adding like we did in the previous one, we're going to subtract this time. Now make sure that you put your hypotenuse squared minus the leg squared. Always put the bigger number squared when you're subtracting. 10 squared is 100. 5 squared is 25. It helps to know your perfect squares. It just makes things easier and quicker. 100 minus 25 gives you 75. So I have a radicand of 75. What is the square root of 75? Is 75 a perfect square? It's not. But there is a perfect square that goes inside of it. And I know this one. Some are a little bit easier. Some you have to go looking a little bit. But here's the idea. I'll go back to the list again just so you can get some practice with this. 75 would live right here. 64 does not divide evenly into it, and neither does 49. Neither does 36. But 25 definitely goes into 75. And it's going to go in 3 times. So I'm going to put a 3 under that radical, and I'm going to put a 25 under this radical, and I made it orange because that 25 is a special number. It's special because it's a perfect square. The square root of 25 is 5. The square root of 3 doesn't simplify. There's no perfect squares that go into 3, so you just leave it as the square root of 3. I know that might look a little weird, but that's your answer. Don't call it the square root of 75. Don't call it 8 point whatever. It's 5 times the square root of 3. That's your answer in simplest radical form. And you might think to yourself, well, how do I know that's not bigger than 10? 10 has to be the biggest side. The square root of 3 is less than the square root of 4. The square root of 4 equals 2. So 5 times 2 is 10. This is less than 2. So this whole answer is going to be less than 10. If that makes sense. Find the area of an isosceles triangle. We're going to find the area of an isosceles triangle with side lengths 10, 13 meters, and 13 meters. To find the area of a triangle, you need to multiply the base of the triangle with the height of the triangle. Now, if you look at this triangle right here, this is the height. We don't know it, but this is the base, and we do know it. So this is really like, I don't know, like a 4th grade problem, except we're going to throw in some Pythagorean theorem so we can find this height. The base we don't know, but we are going to find. The height the base we do know. The height we don't know. The base we know is 10, so we're going to put a 10 right here. 1/2 10 times a number. Okay, now if this is an isosceles triangle, remember we know things about isosceles triangles. We know that this piece and this piece are the same. So if I was to redraw the right triangle, there's your height, there's your 13, this is 5. 5 something and 13. If you know it, great. If you don't, you can figure it out just like we did on the last slide. But I'm going to go back and show you 5 something and 13. 5, 12, 13. It's a triple. So this is one of those situations where if you know your triples, you're going to get your answer really, really fast, really, really quick, and it's going to save some strain on your brain. So this height is definitely 12. So you take that guy. I'll make it a different color, not just because it's a special number, but it's something that you calculated. These you kind of already knew, this you had to find. Now, you can type this in your calculator if you want, but you don't have to. This is really easy. Half of 10, that's 5. 5 times 12, 60. Now, this is an area. You're multiplying meters times meters, so your unit's got to be meters squared. Right, now you could have done it this way also. Half of 12 is 6. 6 times 10 is 60. So you're going to see problems like this on your assignment. Okay, now these are exactly the same, except I think maybe finding the height would be more of a challenge. Okay, so I'll go through this a little bit quicker. Area of the triangle is going to be 1/2 base times height. I know my base is 30 feet. Oops, I didn't mean to cross that out. The base is 30. The height we don't know, but we're going to find it. Okay, so here's our right triangle. Remember, it's isosceles, so these pieces are the same. That's your height. That's 18. That's 15. What is that height going to be? Well, you could spend some time looking at your triples if you like. Now, if you don't find a triple in, 5 to 10 seconds, maybe it's better to just type it into your calculator. I'll come over to the side. Actually, I'm going to come up here. The height for this one, that's a leg. So I'm going to take 18 squared minus 15 squared to get my answer. Now, if I type that into my calculator and take the square root, it's going to give me a decimal. I want the exact height. So I need to use simplest radical form, which again is another skill that we practiced. So what is 18 squared minus 15 squared? You can do that. It gives you 99. So that's your radicand. That's what the height is. It's the square root of 99. Now, to simplify that, you need a perfect square that goes into it. I know what it is because I've done this for a little bit longer than you. 9 goes into 99 11 times. And 9 is a special number. It's a perfect square. It came right from your list. The square root of 9 is 3. The square root of 11 does not simplify. There's no perfect squares that go into 11 besides 1, but 1 goes into everything. So this guy is what you had to find. So I'll make him a different color. 3 square root is 11. That's your height. You could say this as 3 times the square root of 11 or 3 square roots of 11. Now, you need to simplify this. 30 times 3, that's 90. Half of 90 is 45, and you still have to multiply that by the square root of 11. This is the exact answer. I know this seems weird. Type it in your calculator is going to give you a decimal. You need that square root of 11, so just multiply those 3 together. You can do that in your head. Don't forget your unit. The unit's got to be squared. Okay, last one. I know this is going to be 10. Area of my triangle is 1/2 base times height. I know my base is 20. The height I don't have, but I can find it. I know triples, 5, 12, 13. Now you might say, well, these numbers don't appear here. Yeah, well, what if you multiply them by 2? Wouldn't you get 10, 24, 26? You would. 10, 24, 26. I found that without doing any work and any really hard melt my brain thinking. I know it's 24. That's the height. So here's your answer. And notice how there's no radical involved in here at all. So your answer is in simplest radical form. Half of 20 is 10. 10 times 24 is 240. And don't forget your unit needs to be squared. Meters squared. You're going to see problems like this on your homework.